Today we're going to be speaking about exponents, and before we start properly we need to look at some vocabulary, because mathematics is a language in itself, and unless you understand the words that are attached to mathematics you often don't know what's going on when somebody is explaining something to you. So let's start off by looking at 7 squared, or we could also call it 7 to the power of 2. And first of all, we're going to look at that whole thing. That whole thing, 7 squared or 7 to the power of 2, is called a power. But if we look inside the circle, the power is made up of 2 parts. It has a big number at the bottom, which is very conveniently called the base, meaning bottom. And then it has another smaller number which appears to be floating up in the air, and that number is called the exponent. So as soon as you hear somebody speaking about exponents, you know that you're going to have one of those little numbers floating up in the air somewhere. So let's look at how an exponent actually works. What is it actually meaning? So if I take 2 to the power of 4, this is a power, and it's got a base of 2, and it's got an exponent of 4. And that means that I have to multiply the base by itself that many times. So I've got to say 2 times 2 times 2 times 2. And if we work that out, we've got 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now once we get onto all sorts of different calculations and things, we haven't got time to write that out all the time, and it just doesn't make sense to do so, because we're going to learn some exponential laws. So this is where I say to people, especially when this exponential number is quite big, use your fingers, because then you keep track of how many 2's you've multiplied by themselves. So you would go 2 times 2 is 4, times 2 is 8, times 2 is 16. And in that way you would have made sure that you did multiply the correct number of 2's together. So to make our lives easier when we're working with exponents, there are some exponential laws, and once you start doing calculations, all you're really doing is applying the rules. So if you learn the rules properly and understand them, then you don't have any problem with what I'll be doing in future videos. So let's say, for argument's sake, we've got a to the n times a to the m. Right, to notice here what's going on is this has got a base of a and that's got a base of a, and the exponential rules only work if the bases are the same. If the bases are the same, then your answer is going to also have a base of a, and because these two are being multiplied together, you're going to add the exponents. So if we look at what that means in an actual example, because sometimes all these letters, which are known as variables, can be confusing. Let's say, for instance, the a value was 2 and the n value was 7. Then we'd have 2 to the power of 7 times, I need to have the same base value, and for m I'm going to choose a value of 4. So then, applying the rule, are the bases the same? Yes, they are. So the base will stay the same, and what do I have to do to the exponents? I have to add them, and so actually my answer is 2 to the power of 11. And if I wanted to find out what that was equal to, I would have to keep going. 2 times 2 is 4, times 2 is 8, times 2 is 16, etc., etc., except in the higher grades you'll be allowed to do that on a calculator if you needed to work it out, which usually you don't. Then we get another law that people confuse very much with the first one. It says a to the power of n raised to the power of m. So before I even show you what to do, let's try to see how do we tell the difference between these two, because that's what people struggle with. This one has got its own base times another thing with its own base. So there are 2 bases. This one's a base raised to a power, and then that whole power is raised to another power. So there's only one base here, and also there's 2 floating numbers which are called exponents. So what am I going to do then? My base is still going to be a, but I'm going to multiply the 2 exponents together. So let's test what happens with real numbers. I'm going to again choose 2 to the power of 7, and I'm going to raise it to the power of 4. So that means, according to the law, that I have to keep the base of 2 and say 7 times 4, which will give me 2 to the power of 28. And as you can see, those are two completely different answers, and that's why you've got to be very careful not to mix those two rules up. Then I get on to a to the power of n divided by a to the power of m. And very often, especially as you get further on in your studies, it won't be written like that. It will be written as a to the power of n over a to the power of m, because this division line here actually means divided by. So the rule there, thinking that multiplication and division are inverse operations, so it's likely that what we do is going to be an inverse operation. I'm going to say the base of a, keep that the same, to the n minus m. And with an actual example, let's say 2 to the power of 7 divided by 2 to the power of 4. Remember, a better way actually of writing it is 2 to the power of 7 divided by 2 to the power of 4. And the rule says write down your base number and subtract the exponents, which would give us 2 to the power of 3. And we can work 2 to the power of 3 out very easily, because 2 times 2 is 4, 4 times 2 is 8. So we could easily convert that into a whole number. Another rule is that a to the power of 0, any number to the power of 0, is equal to 1. So even if your base number is a huge number like 98, if it's raised to the power of 0, it's 1. So wherever you see any number raised to the power of 0, you immediately, in your next step, put 1 in its place, replace it with 1. And then we get on to a to the power of minus n. So a to the power of minus n is equal to 1 over a to the power of n, which confuses a lot of people, and they just don't seem to be able to see what's going on or remember what's going on. So I'm going to prove to you that this is equal to that. So the way I'm going to prove it to you is by saying, let's use this rule here on the 1, but use the rule in reverse. So 1 can be replaced with a to the power of 0. Because remember, with all of these rules, we've learned the rule this way, but you can use it in reverse as well. So instead of 1, I'm going to write a to the power of 0. And this is over a to the power of n. Now I've got this rule, because it's a division situation, remembering that this little line means divide. So when I'm dividing two powers, I have to subtract the exponent. So I keep the exponent of a, and I say 0 minus n. Well, if you think about your work of integers, what is 0 minus n? We'll think of it with real numbers to help you a little bit. So let's say 0 minus 4. What would 0 minus 4 be? It would be negative 4. So 0 minus n is negative n. And there, I've gone back from that side of the equation. I've written it in different ways using exponential rules. I haven't used anything illegal. And I've worked my way back using two different exponential rules to get back to that. So I'm proving to you that that is equal to that. And in future videos, I'll explain to you how to apply this rule in the easiest way possible. I hope this has been interesting, and I hope it's been helpful. And there are going to be many more videos on how to apply these exponential rules in the easiest possible way.